In the early 1900s, a horse named Clever Hans absolutely stunned audiences across Europe by solving arithmetic. I mean, picture this, a literal horse doing math.
Okay, let's dive into this. If you asked him, say, what 3 plus 4 was, he'd stand there and tap his hoof perfectly, exactly 7 times. Every single time. It was mind-blowing.
Naturally, looking at this wild phenomenon, people just assumed the horse could count. I mean, what else could it possibly be, right? Well, it turns out he couldn't. He absolutely could not do math. When investigators finally really dug into it, they discovered the actual secret. Hans was just reading his questioner's body language. You see, the people asking the questions would unconsciously tense up as he got closer to the right number, and then, boom, they'd relax the exact moment he hit it. Hans just learned to watch for that tiny physical relaxation, so he never learned math at all. He just learned a shortcut. Now, the whole point of this explainer is that if we fast forward to the modern era, machine learning models are doing the exact same thing. And honestly, it's one of the sneakiest, most dangerous problems in artificial intelligence today. You can actually have a model hit 90-something% accuracy while learning absolutely nothing about the actual subject you wanted it to learn. 90%. But it's totally an illusion. Because just like Hans, the AI didn't actually learn the complex logic you were trying to teach it. It simply latched on to an easier, completely unrelated pattern that just so happened to correlate with the right answer in its training data. Here is the core thesis we really need to understand. Models are lazy in a very specific way. Listen, if you give a model any shortcut that successfully predicts the label, it's going to grab it. It doesn't care at all whether or not that shortcut has anything to do with reality. And this brilliantly illustrates what is probably the absolute clearest example of this problem. Researchers built a model to tell wolves from huskies, two animals that look startlingly alike. At first, it performed great. But when they dug into what the AI was actually looking at to make its decisions, no way, it wasn't looking at the animals at all. It was looking at snow. See, the wolf photos in the training set were mostly shot out in the snowy wilderness, while the husky photos were mostly shot in, people's yards and living rooms. So the model learned a super simple equation. Snow equals wolf. That's it. Which means, if you showed this supposedly highly accurate model a picture of a wolf standing on green grass or a husky playing out in the snow, it fell apart completely. It failed because it was only ever looking for the background. So, the crucial point is, this is exactly why sanity checks matter so incredibly much before you ever trust a model. You literally have to actively step in and stop this shortcut problem from happening. How do you do that? Well, step 1, you have to ask whether the important features it's using actually make sense. Like, would a real-life doctor or a teacher actually expect that specific factor to matter in the real world? Then, step 2, you have to test the model on deliberately different data. Let's move to and see how this builds in practice. You have to introduce deliberate variations. You take the model and you test it on entirely new backgrounds, completely new hospitals, or even just data from new years. You do all of this to see if the model's performance actually survives when the environment changes even a little bit. Because ultimately, a model that's right for the wrong reasons isn't actually right. It's really just waiting for the moment the shortcut disappears. So, the next time you see an AI boasting flawless accuracy, you have to ask yourself, is it truly intelligent, or is it just another clever Hans?